Okay, this video is going to be a little bit longer, but it's going to talk about sort of a couple main types of chemical reactions that we're going to classify here. The first type we're going to talk about is a combustion reaction. You've probably heard the term combustion before. A combustion reaction is going to occur when a substance reacts with oxygen to produce energy in the form of heat and light. So, for example, when something burns, as shown in the image, that is a combustion reaction. A synthesis reaction, you can sort of think of what that word synthesis or to synthesize something means. To me, it means to create something. A synthesis reaction is when two or more things combine to form another substance. So, for example, A plus B makes AB. So here's sort of a picture of two people. This guy and this girl come together to make this couple. Or, for example, here magnesium and nitrogen come together to form magnesium nitride. So two separate items come together to form a single combined item. They are synthesized together. A decomposition reaction, again, you can think of what that means to you. When I think of decomposition, I think of decomposing, things breaking down. A decomposition reaction occurs when one substance breaks down or decomposes into two or more substances. So that's basically the opposite of a synthesis reaction. And so if we look at this equation, it's AB makes A plus B. So here we have an example. Water can turn into hydrogen and oxygen, or in the case of the couple that we had before, A and B together can make A separate and B separate. A single displacement, or rather a replacement reaction, so if we think of single displacement, one single thing being moved around, is when one element replaces another in a compound. So here's an easy way to look at it. A plus BC equals AC plus B. And so here, A replaced where the B was, and B moved out by itself. So here's a real example. Iron plus copper sulfate makes copper plus iron sulfate. Or I couldn't possibly remember the names of these Flintstones characters, but you can see the exact same situation here. The two women are changed out in this case. Double displacement is sort of an extra thing on top of single displacement. In double displacement, the positive ion on one compound replaces the positive on the other, and here we form two totally new compounds. So if you look at this, I have AB plus CD equals AC plus BD. So I basically switched what things were with, and so you can think of that here. I can have AB plus CD now makes, here I have CB and AD, another type of displacement. The same thing, we're just switching. Here we switched where the blue and yellow are and where the green and red are. Oxidation-reduction reactions are sort of interesting. An oxidation reaction is when an element loses an electron. We'll call it oxidized. And a reduction happens when an element gains an electron. And so that sort of makes sense because you're gaining a negative, okay? Negative, right? You're being reduced, okay? Hence reduction. You're gaining that electron. And so oxidation and reductions tend to occur in a pair. One atom gains and one atom gains and one atom loses, and they tend to occur in a pair as oxidation-reduction reactions. And so here we can see atom A starts with the extra electron and gets oxidized. So now we have A, which is oxidized, and B gains that electron, and then we ended up with a version of B that is reduced.